Okay. So, in order to instantiate from a catalog, we have to set up our knowledge environment. So everybody in this file, press F10 to go to options. And then with this window open, in general, we're going to go to parameters and measures and the knowledge environment tab. It might take a little while to get this tab open, but the bottom path, the knowledge environment, we need to map this to our KP infrastructure folder that I just sent you. So open the folder, find where you have that KU DP docs folder, and don't go into KP infrastructure, just select KP infrastructure and press select folder. So that should map your knowledge environment to that folder. Once that's set up, you can press OK. And now when you instantiate a Pw Kp or any user-defined feature or document template, it's going to look for that catalog, or the catalog in that location, to pull the Pw Kp from. So in order to instantiate the Pw Kp, we need to place that Pw Kp into the catalog so that when it's pulled up, it'll instantiate. So back in the pw folded panel file, we're going to open the catalog in that instance. So go to the KU DP docs folder, navigate to KP infrastructure, and knowledge resources catalogs. I placed an empty catalog in there called, well, it's not empty, there's one Pw Kp in there. We're gonna have to update it. So just grab that catalog and drag it into the Pw Kp instance of DP.
Is this just from open, file open? Here?
You could do that too. File open, or from the folder, drag it open. So now I've got in my,
What folder is it?
it's in the, let me show you. So inside KU DP docs, there's KP infrastructure, knowledge resources catalogs.
What are the two first files?
The two first files?
You have PW folder and
Inside, so there's PW folder panel and Pw Kps, and in task 4, there's task 4 contacts. Okay. So in the catalog, expand the chapter on the left, this blue band, expand chapter. And double click on knowledge resources. You all should see the PW folded panel. That's one that I entered and when I was testing this out on my computer, so you're gonna have to delete that and reinsert the Pw Kp into the catalog. Select it, press delete, and say OK. Now you have no Pw Kps in your catalog. The right-hand menu in the right-hand toolbar, there's a little blue page. It looks like a blue page icon. Add component. Select Add Component. And now we're going to select External Feature. Select External Feature. Go over to the PW folded panel. You can do that if you have it. If you have the catalog maximized, you can go through the window the window drop-down menu, PW folded panel. There's a power copy in the tree. PW folded panel, select that. And you see it replaced the name field in the description definition window with the name of the power copy. Copy that. Go to keyword values, the second tab, and paste it over my family dot whatever number you have. Go to logical name, paste it over unset. In the type field, we're going to pull down and go to power copy. In usage, I'm going to just type in here instantiate the folded power copy. Folded panel power copy. And we can leave the project blank for now. So your window should look like this. If it doesn't look like this when you instantiate, you're going to get an error. Yeah?
So I know the log pretty early, so after we click delete on the one, where did we go after that?
This button right here, add component.
Ah, okay, that's where I was.
And then you can press OK. So and save the catalog. Make sure you save the catalog. Because what's going to happen now is we have a knowledge pattern in the other file, and we're going to instantiate a power copy that contains a knowledge pattern. That knowledge pattern is going to look in this catalog for this power copy and place it in the model iteratively. I'm going to show you. Just type inside the field.
Is it okay if we spelled out power copy instead of PW?
No. It depends. Where did you spell it?
In usage.
Oh, in usage, yeah. Usage is just kind of like your note. Yes. Okay. So then I'm going to close the catalog. Do I want to save? Yes, I want to save. And now I've got my power copy here. And I made this context file for you. I also gave you, well, before we go into what I gave you, let's just look at how I made this, if you haven't already. I have a geometric set with some planes. I have a base spline, and then I have a cylinder geometric set. Inside the cylinder geometric set, I have a sweep surface. And that sweep is sweeping a circle along a spline, where I've defined the radius as 96 inches. There are other options. So in the sweep command, just to familiarize yourself with the sweep command, the first type of sweep, using this button, is sweeping a profile that you define over a curve, a guide curve that you define, with other ruling factors. The second one is ruling supports. The second is a line, sweeping a line along a guide, or two guides, or a reference curve, or a guide with a reference surface. The third type of sweep is what I used with the circle, so a circle sweep. And the fourth I haven't ever really used. But it looks like it's an interpolated surface using multiple guides. So cancel that. Then I split the surface with a plane, intersected the surface with that plane to get some lines, created a point off in space, and the only reason I made that point is so that I could pull out that intersection into separate lines. So when I intersected the split surface with the plane, I have a non-connex curve, a curve with two domains, but I wanted to pull out the domains of that curve as separate objects, curve objects, so that I could use them to create points. So I used that first by making a near of the intersect with that point. And see, in the near definition, I can create a near or a far. So the first one is a near to the point, the second is a far to the point. So it's returning the closest and the farthest objects of that intersect. From there I make some intersections. I made some circles. I projected the circle onto the cylinder. Well, it's not really, it is a cylinder, I guess. And then I split the cylinder with those projections. The last thing I think we all should do is move this cylinder, move this split surface. So if you select it in the model and you right click, split to object, change geometrical set, select context, and it's going to automatically put it in the last position there. Press OK, and then I'm going to rename this split sil surf. Okay, now this is going to be the context that we're going to instantiate the power copy onto. So in order to instantiate the power copy, we need to create the base geometry for it, like a wireframe geometry. So we're going to start by subdividing the spline into planes. Then we're going to intersect the surface with those planes to create lines. And then we're going to create a bunch of points on those lines that we'll use as the 4 corner points for our power copy. So I gave you a couple of power copies that I use on a very regular basis to create this kind of automation environment. So inside power copies, there's the PW folded panel that we already have open in a different instance of DP, and then we have automation. In here we have a smart divide power copy, which is my personal favorite. We have an intersect surface with planes that's going to build on the product, whatever's created in the smart divide. Then we have a smart divide list on a list of curves, which is going to give us all of our points. And then we have our instantiate folded panel. So we're going to build the model with these little power copy chunks that's going to produce lots of geometry and place them in lists, and then we're going to pass the list from one to the next to continue to build more and more support geometry. So in our context, go to curves, right click, define and work object, and we're going to insert power copy, the first power copy in this sequence that we need to instantiate. So insert from the top, advanced replication, instantiate from document. Now, let's navigate to that folder. Power copies, automation, Pw Kp Smart Divide. Double click on it. And this power copy has one input, a curve. So everybody select that base spline in the model or in the tree if you want to find it in the tree. Press OK. And it just dropped in a geometric set called Pw Smart Divide Set inside curves. And if you expand that, you'll see we have a reference geometric set, some points, planes, line segments, join line segments. Inside the Kp relations is a knowledge pattern. We haven't done any knowledge patterning yet, but that's really what we're going to be dealing with today, is how knowledge patterns work and the kind of the power that they contain. Just to start, we can play with the control parameters before we get into anything with the knowledge pattern. Here we have a name. Let's change the name from PW to div PLS, basically division planes. Press enter. The knowledge pattern is going to run automatically because it's set to run automatically. And you see it's renamed the geometric set div planes. And if you go down in the tree, you can look at inside the points geometric set. It's created 4 points and it's called them div planes point 1, point 2, point 3. If you expand planes, you have div planes plane 1, plane 2, plane 3. Right now we've got the division type setting to by target spacing. We've got the spacing at 60. We're generating planes, yes. The plane orientation is normal to curve. And we're not generating line segments. So this is all just kind of, this was the last state of this file when I saved it, so that's what you could consider then the default values for these parameters. Reporting parameters are just a little information about what's being created. Resulting segments. So when we do target spacing, our spacing is 60, our set spacing, our target spacing is 60 inches. The resultant spacing is 68.06, etc. And we're getting 3 segments. If we go up here and we change target spacing to max spacing, press OK. That value of 68 has now become 51. So what we've told the knowledge pattern is that 60 is our target spacing, but we can't go any greater than that. We want to equally subdivide this curve into equal segment spaces. So do the math, find the length of the curve, divide by 60, and then give me the remainder so that it's an even spacing. The difference between 60, our target spacing, and 51 is greater than 68 and 60, which was the target spacing. So target spacing, it doesn't matter, it can go above that spacing, it can go below that spacing, it's going to find the closest equal spacing to the value. Max spacing says we can't go above 60, find the closest equal spacing of the curve to that value. And that's really handy for laying out these clips where they have to be no greater than 12 inches on center, but they can be less. So if I set a max spacing to 12 inches and then I divide that curve up and the optimum spacing is 11.6 inches to get equal spacing between them, then the power copy has kind of done the math for me. So we can play with this more. Let's say we have max spacing. Let's change the spacing from 60 to 24. Now we have 9 segments spaced at 22. We have our planes, we have our points. If we wanted to change the planes to no longer be normal to the curve. We can double click on normal to curve and make them horizontal. So that's kind of the control of the power copy. And now we can kind of go into the guts just to explore what that looks like. If you double click on the Smart Divide knowledge pattern, it's going to push you into the knowledge template workbench. And then if you double click on it again, it's going to open the window of code that processes those parameters and the curve as an input and outputs the points and the planes. So this is knowledge pattern code syntax. I don't know if it's like any other coding language. This again it's self-taught, but over the years I built a little reference. Something I probably should have included in the email I sent you. I'll send it again to you later in case you decide you want to get into this coding. And that is just a messy note text file. That's just useful things that I've come through over the years, that whenever I need to instantiate a power copy, I can go here, copy paste, change a couple of values, and not have to write it all out from scratch every time. But so this is the power copy, or this is the knowledge pattern. You can look here, curve, here I've set curve ref equal to the base curve, and that's the curve that we input when we inserted the power copy. From there on, whenever I'm using that input curve as a reference to do math or to put a point on it or whatever, I'm referencing curve ref. Sorry, I should have added. Here it's being declared. Here it's being defined, and then here it's being used as a reference to measure the length, to divide by the spacing, to figure out how it's going to put points on that curve. And then here it's actually looping through, placing points on the curve, and in this case, this is an interesting line. This line is creating a point object in the tree. Here it's defining that point object, and here it's naming that point object. So when we're modeling in the tree, we create a point over in the toolbar, and it brings up the definition window, and then we create that point, and then it gives it a name, but usually we go back and we change the name. That's 3 steps, kind of the clicking of the button to create the tree, to create the object in the tree, defining the object, and then renaming the object. In this code, it's the same 3 steps. You create the object in the tree, you define the object, and then you assign it a name. You don't have to assign it a name, that's kind of an optional step, but since I'm picky about that, it's a necessary one for me. And then some of the other stuff. So that's how the knowledge pattern works. There's also lists that are created. These lists you see are underneath the knowledge pattern. They're contained in the knowledge pattern. So if you expand the knowledge pattern, you see I have a div planes points list. This list of points is basically a container for all of the points in the tree. And the points are placed in the list when I create the object in the knowledge pattern. So I create the object point, I place it into this geometric set, and at the same time I place it into this list. So if we close this window, just say okay. Oh, and the last thing I'll add is, here's where it's set to manual or automatic execution. When automatic is selected, every time an update is triggered in the model, this knowledge pattern is going to run. If it's set to manual, you have to manually run the knowledge pattern. If we hit OK, you manually run it by right-clicking on it, Smart Divide KP object, execute or execute an upgrade. So I just forced an update on the knowledge pattern to re-execute, and it redefined these points. If we look at this list, if we double click on the list, it's going to show us the contents. Contents being div planes point 1. Well, there it is, it's in the tree. So I can instantiate another power copy with a knowledge pattern in it that references this list, that builds more geometry, places that geometry in a list, and continue that process to build a smart model. So I close that. We have our planes, and now we want to create intersections on this surface. And the other thing I should add is we build these power copies because it extends the functionality of DP beyond the built-in standard tools. You can do some of these things in Digital Project. You can make repetitive points, but once you make those repetitive points, the parameters that you use to define them are lost. When you build a Smart Divide power copy like this, you build those repetitive points, but you maintain the logic and you retain control of the parameters that you use to define them. So now let's create some intersection curves. So insert, advanced replication, instantiate from document, and let's select intersect surface with, well, intersect surf with planes. You guys have an error? You guys were back in, you guys were still in the knowledge template workbench. If you just double click on a geometric set, it'll bring you back to either geometry, or right now I'm in architecture and structures workbench. If you want to go through the menu, go up to start, project center, geometry. My computer is running really slow right now, so when I instantiate some of this stuff, it's going to take longer. I don't know why it's so slow. Okay, so is everybody back in the geometry or architecture and structures workbench? Okay, so insert, advanced replication, instantiate from document, and let's intersect surface with planes. Okay, so when we inserted our first power copy, it asked for a curve, and it created a list of planes. Now, this power copy is asking for a list of planes and a surface. So we find the list of planes in our Smart Divide power copy, div planes planes list. Does everybody see where I'm getting that? Select that, and the surface, let's start, we're going to change this later, but let's start by selecting the trimmed, the split surface in our model as the surface input. And make sure we don't want to put it inside div planes smart divide set. We want to put it after. I don't think you have to. No, you don't have to double click. So if you press OK, it dropped a surface plane intersections geometric set in the model. Let's collapse that, expand that. I'm going to change this. This one looks a little bit different. This power copy isn't as refined. So we'll change the string name from int to, I'm going to call it the PW base curve underscore.
How did you edit that?
Double click on the string name. Yep.
So is that, it's not changing the name, like how we usually change the name?
No. The knowledge pattern is changing the name. Press OK. And you'll notice this one didn't execute right away, because this one is set to manually execute. Let's change that. Let's set this one to automatically execute. So expand the intersections KP relation set. Double click on the KP. Double click again. And all we want to change here is change from manual execution to automatic execution. And press OK. And now it's gonna, you saw the little window, at least on my screen, pop up. And it's generated intersections. Not okay, before we play with this, double click on a geometric set to bring you back to the workbench you were in. Expand the Smart Divide Power Copy geometric set and hide the points. Leave the planes on, but hide the points. The PTS, hide the PTS geometric set. And now, if you want to see how this all behaves, you can select one of these base points that define the spline that defines the surface. And my computer is really slow right now, so it's going to be a bear to update. But if yours will probably move faster. If you start to move that point around, it's going to, you'll see it constantly updating. Yeah, my computer's very unhappy. I'm just gonna give up. It might give you an error if you push it too far. Yeah. There we go. One thing I would caution against is making your surface too big, because we're going to instantiate power copies on this. We're going to instantiate the folded panel on this, and if you have a really big surface, you're going to have a lot of power copies, and it's going to take a really long time to
These guys aren't giving me
create.
the surface to the knowledge pattern to execute.
They didn't switch it to automatic update.
No, I just did it, but it's
Okay, one trick to moving the point. I'm going to first change my setting so that it's not automatically updating, because I don't want these knowledge patterns to start to... I don't want these knowledge patterns updating as I move my point, because my computer is so slow right now. So if you press this button, it changes manual update mode, or it switches to manual update mode. So now you can make any changes in your model without triggering an update cycle. Now I can grab this point by double clicking on it to get my point definition window. Nothing is going to move. When I double click on that point, nothing is going to happen. It's just going to bring up the window. When I click off in space, that point is going to start to move then. If I click on the circle, the point definition window is going to think, you want to make this point on a curve now. or by ratio on or length on a curve, not on a plane anymore. That's problematic because the circle in a roundabout way is based on the point. Because the circle was built on the intersection of the surface, which was built on the sweep, which was built on the curve, which was built on the point. So now you've created a circle of dependencies that the software cannot resolve. So you want to be careful that when you're moving this point now, you want to keep it free of the other objects in the model. And then when you want to finish the move, let's just say you get it somewhere that you like, double click in space where you want it, and it's not going to move anymore. Then you press OK in the window, and the point is where you want it. Then if you want to update, there's a couple ways you can do it. You can select this Update Geometry button, or you can go to the top of the tree, to the part, right-click Local Update. Now everything is going to execute, and you'll find out if the move that you made with that point is catastrophic or not. Mine was catastrophic. No, it was not. Okay. This is one of the downsides to knowledge patterns when you have them set to automatically update. Is if you want to change your model, you want to do it very slowly and incrementally. That's why a lot of knowledge patterns I make are set to manual update, not automatic update. And that's why changing the model like this, I try to do with a parameter rather than just making kind of arbitrary points on a plane and then moving those points. A lot of times I'll construct geometry with planes and then drive the planes as offset with offset values, with offset parameters, intersect those planes to get points, draw lines between the points, or intersect planes with planes to get lines, intersect those lines with planes to get segments of lines, and build geometry that way. This is really just an example to get started to play with power copies and knowledge patterns. Okay. I'm going to leave. Some people like to keep their model in manual update mode. I generally don't. So I'm going to change that. Because my computer is running so slow though, I am going to switch these knowledge patterns to execute manually. So I'm going to double click on the knowledge pattern and switch this to manual execution. Press OK. And I'm going to switch my smart divide to manual execution. The other thing that I noticed is the smart divide has this box checked in the upper right. Optimize memory, no undo. That's why you can't undo if you make a big mistake, because every time this knowledge pattern updates, it's erasing the undo. And every time you move anything in the model, you're triggering this knowledge pattern to execute, which is erasing your undo. So if you want it to run, if you want to be able to undo from this, you can uncheck that. But because I'm changing this to manual execution, I'm going to leave it checked. Plus my computer is so slow already, I'm going to leave it checked. Now you'll notice if you go to change one of the values in control parameters, I'm going to change the spacing from 24 to 48, so I'm not instantiating so many power copies. Double click on spacing, change to 48, press OK. Nothing happened. I need to actually right click on Smart Divide KP, go to Object, Execute and Upgrade, Now the planes have updated, but the intersections haven't. So I need to go to my intersections, right click, and execute an upgrade. And there go my intersections. Okay, before we instantiate the next power copy, I want to switch the intersections so that the curves are intersecting the half of the cylinder, not this split cylinder. So right click on surface plane intersections geometric set. Go down to surface plane intersections object, edit inputs. And now these are the inputs that we selected when we inserted this power copy. I want to change split cylinder surface. I'm going to go up in the tree. I'm going to expand cylinder, and I know what I want is split.1. This is where it's very, very helpful to have proper names. I was in a rush making this file, so I didn't give this a name. I should have. I should have called this cylinder split so that it was obvious that this was my cylinder being split. Just like I should have named sweep.1 my cylinder sweep. Because if I have 3 sweeps in this model, cylinder sweep means something. Sweep.1 doesn't. If you right click on the surface plane intersections, edit inputs. And then instead of split cylinder surface, inside the cylinder geometric set, there's split.1. Once you select that, you can press OK. I'm going to collapse the context geometric set and then execute that knowledge pattern. Now we have the intersections.
When you go to execute, is it also update?
Nope. Go to the object, execute an upgrade. Yeah. Okay, so now we have lines, these intersection lines that extend past the trimmed surface. They're using that split surface, the first split surface. Okay, so now we need to make all the points for the power copies, to use as base reference when inserting them. So insert, advanced replication, instantiate from document. Now we're going to use the smart divide list of curves. Cool. List of curves is going to be the intersections list that's produced in the surface plane intersections. So select intersections and then make sure you change the destination from inside to after surface plane intersections. Press OK, and you can see I just made this power copy actually before class. So with the inputs for this were a different state of this model actually. If you open that power copy, it's going to look a lot like this because I just pulled it out of this model. So now I have all smart divide set. And this one I believe is not set to automatically update. So right click, smart divide KP object, execute an upgrade. And now we have a point grid on all of those curves. Hmm?
It's everywhere.
You can see how we're starting to chain these little nuggets of logic to create something that's greater than the parts. I'm going to tweak these circles. I'm going to make the circles a little bigger. You don't have to do it, just, I mean, like, I wouldn't recommend that you make your, maybe you make your circles a little smaller. Just so there's, well, no, I don't actually like that either. I'm going to leave that. I'm just going to get the proportions of this right because I know what's going to happen. I know what's coming.
Trying to get the surface so that I can make the skin bar. Add some surface area.
Okay, so I need to make sure that this is all properly updated. Okay, is everybody here? Everybody has points? Let's just look and let's open up that knowledge pattern and see what it's going to do. Oh, sorry. This one isn't the instantiator. Let's instantiate the next power copy and then we'll open it up before we instantiate, before we execute it. Okay. So go back to insert. Make sure you're in the right workbench. Insert, advanced replication, instantiate from document. And there's the Pw Kp instantiate folded panel. That's what we've been working towards. Now this is going to take a little more. This is going to, let's first, I'm going to change destination to after. Pw planes list. That's the very first list of planes from the smart divide. So let's expand smart divide. Expand Kp, expand smart divide Kp, and select the div planes list. All points list. All points is that grid of points that we just created. So let's collapse the smart divide, go to all smart divide set, expand Kp, expand smart divide, select the all points list. Split cylinder surface. That is the split cylinder surface. And then near curve. Near curve we forgot to build. So for now, before we execute, or while we're instantiating this power copy right now, let's just select the spline for the near curve. So now near curve is the base curve.
Grab the div. Which is the near curve.
The near curve is the base
The
curve.
spline.
The spline, yeah, the base spline. And place this after the all smart divide set. Split cylinder surface, I moved it immediately in context under cylinder. You might still have it. I renamed it also at the beginning. You might still have it around one of the trims, or you might have moved it completely. It's this surface that's visible on my screen right here.
Can we just click on the surface?
You can click on the surface, yeah. You don't need to find it in the tree. Does everybody have this? Press OK. All right, now we're not going to execute that yet because we need to, well, let's make a near curve. At this point, I'm gonna hide some things in here. I'm gonna hide those planes because I don't need to see them. We'll leave the curves visible. I'm going to hide the circle. Don't need the circle right now. Oops. Don't need that circle. Find cylinder geometric set. Right click, define in work object. And let's make a new geometric set. Right click, properties, let's call it the near curve. For the near curve, I'm just going to make a bunch of planes and then make a polyline. Because we haven't made a polyline yet, I'll show you how to make a polyline. So I'm going to, with near curve geometric set as my active work object, I'm going to double click on point, in the toolbar, the point toolbar. And I've got my base plane visible. So I'm just going to put a couple points, 3 or 4 points on my base plane. Randomly, just on different sides of the cone or the cylinder.
How many are you placing?
I placed 4. 2 on one side, 2 on the other. And now, underneath the line, if you press a little down arrow next to line, the third option is polyline. And then I'm just going to select those 4 points so they zag across the surface. I do not want to grab point 41. Try not to grab point 41. If you accidentally grab point 41 like I did, select it, either press remove or press replace. I'm going to replace it with a different point. And press OK. I'm going to right click on this and rename it near curve. So right click, properties, near curve. The polyline that I just made. I'm going to call it near curve. Enter. And then down in this instantiate panels geometric set, that's the Pw Kp instantiator that we just instantiated. Right click on that. Go down to instantiate panels object, edit inputs. We want to replace the base curve with the near curve.
Polyline near curve?
Right. That polyline that we just made. Once you press OK. Now let's look at what's happening. Now let's open up this instantiate panels knowledge pattern and have a quick look. So double click and it brings us to knowledge template workbench. Double click again. And this section is the only real interesting section that I'll show you. There's this if statement, and the if statement is basically saying I don't want to instantiate panels where there's no surface. I only want to instantiate panels where I know all 4 points land on that surface. So I'm In this little bit of code, I'm defining my 4 corner points. And then here I'm evaluating the distance of those corner points to the surface. And if the distance of each one of those points to the surface is less than 1 millimeter, then I'm going to grab my KU catalog. I'm going to find the power copy that we put in that catalog, and I'm going to instantiate that power copy into the panel's geometric set. That's what that little line is saying. Then I have the inputs to that power copy are proximity line. If you remember from Tuesday, the proximity line was giving us that peak for the power copy, the peak for the panel. Our right top, right bottom, left bottom points, and then the base surface input. So here it's opening that, it's placing that power copy in the tree. Here it's ending it, and then it's doing a little other something. Press OK. So that's the knowledge pattern, and then execute that knowledge pattern. So right-click, instantiate panels, execute, and upgrade. This is going to take a little while, and the results are going to be kind of unpredictable. Gave you an error. Okay, then it's that first step of defining your knowledge environment. Probably the same for you. Yes. I think actually I'm going to pause this, and then I'll start it again once it's done. Okay, so now we've instantiated our power copies. I am going to hide everything except for those panels because I don't want to see anything else. I just want to look at the power copies right now. And that is not at all what I expected. That is not at all what I expected. If you look at our old power copy, that's what the power copy was. So now we ask ourselves, what happened? What happened? This power copy was based on a surface that has a direction, because the pointy pyramid of this power copy is shooting off of the surface, given the surface direction. My guess is straight away that the surface that we built the power copy on is backwards. Or actually, I should say the surface that we instantiated the power copy on is backwards. I'm going to test it just to see if that's right. By inverting the surface. So invert surface. I'm going to invert my split. Okay. And now you see if I expand panels, these are all my instantiated power copies. I'm just going to select the first one, edit inputs, and I'm going to change the split cylinder surface to my inverse surface that I just created. Press OK. And it updated. Problem solved, but watch out, it's sharp. So now hide this. So, oops. So now if I want to apply that change to all of these, the easiest way to do it is to apply that change to instantiate panels, delete all of the power copies, and re-instantiate the power copies. This will be the last thing I do because my computer is so slow. Then I'll just explain a few things about power copies. If I want to change any of these power copies that have been instantiated, I can go into the geometric set, and you'll see that everything inside of that geometric set is... I'm not even going to bother right now. Everything inside of this instantiated power copy will be identical to the power copy itself, to the original. But now that it's been instantiated, it is its own unique object, its own unique entity in the tree. I can, just like I changed the inputs for this power copy to make it invert, I can go in and I can change the wireframe construction stuff. I can change the parameters that we use to define it. Remember the formula that I had that said there was a max height? Well, now that would probably come in handy. Now I wouldn't have... Let's see, how long is that line? It's not even there. Wrong one. Well, my measure button is like... There. Now my line wouldn't be 92 inches. It would be the max value that I had of 5 inches. So let's say I want to put that function, that formula, back in my power copy. I don't want to change every single instantiated power copy because that would take a long time and defeats the purpose of automation. So what I would do is I would delete all of these power copies from this model, save it, and close it. Go back to the power copy, the original, add that formula wherever it was. I don't remember which one it was. I could go through, I could find the formula, or I could just go to that line, center line, go to that, edit the formula. I can put that max formula back in here so that it never gets above a certain length. Save it, and then open up this context folder again and re-instantiate the power copy. The thing to remember is if you instantiate a power copy into this file, it's going to load that power copy into memory, into the computer's memory. And if you don't like what you see when you instantiate, you delete all the power copies, you go back to the original file, you change it, you save it, and you re-instantiate into this file without closing and reopening, it's going to load the original, the one before you made the changes, because the memory hasn't been cleared. So you have to close the context, reopen it, and re-instantiate. So if you're making a lot of changes to your power copy, you might want to make a lot of changes and then instantiate, see what happens. If you don't like it, delete it, go back to the power copy, make a lot of changes, and then open up the context again and re-instantiate. There's no live connection between this instantiated power copy and the original, which is good and is bad. A live connection would be nice. There are other programs that do live connections, like I think Revit even does live connections between their adaptive components and when they've been instantiated. But Digital Project doesn't have that capability. That's pretty much it. Yeah?